In this video, which is on quotient rule, I'm going to do questions C, D, and E. In the previous video, I went through A and B. So if you want, you can check out those ones. So for this question, we want to differentiate, and obviously we need to use the quotient rule because we have a fraction. And so we are going to start we basically squaring the denominator. That's always the first step in the quotient, using quotient rule for differentiation. So we have ln x squared on the denominator, and then in the numerator the pattern is always the same. So we start with writing down the denominator function times the derivative of the numerator function. So the derivative of the numerator function, we have e to the minus 2x plus e to the 2x. So it's just exponential function, and we always differentiate the power, and then that comes down as a coefficient of the function, right? So I have videos on that. If you are not very confident with this topic, you can go back and watch those videos first. Yeah, so exponential functions, we have exponential functions, and then it differentiates to minus 2, because the derivative of the power of e to the minus 2x is just minus 2. So minus 2 comes down and times e to the minus 2x. So basically that becomes the coefficient of the entire function. And same thing happens for e to the 2x. So 2 comes down, and then you're going to have 2e to the 2x. So this was the first part of your, remember that, numerator, because it was the denominator function times the derivative of the numerator function, then subtracted by, this time the rules change. So this time you have the numerator function times the derivative of the denominator function. So in this case, we write down the numerator function first, e to the minus 2x plus e to the 2x, times the derivative of the denominator function. So denominator function is ln x, so the derivative of that is just 1 over x. And yeah, so this is the answer of this question. You can simplify this, but since we are not asked to do so, let's just leave the answer in this form. Okay, for part D, we have e to the x plus 3 cubed, and denominator is cos x. So again, the same pattern with just different functions. So we first square the denominator function, which is going to be cos x squared, and on the numerator we write down the denominator function first times by the derivative of the numerator function. So for the numerator, to differentiate basically the bracket on the numerator, we use the chain rule. So e to the x plus 3 cubed. So 3 comes down from the chain rule, and the derivative of the inside, e to the x plus 3, just differentiates to e to the x. So it's e to the x times the bracket, but with power basically minus 1, which is 2. Again, I have videos on chain rule, and I have the many examples, so you can check them out if you feel like you need some revision. And then the next part is basically differentiating. So this time we write down the numerator function first, which is e to the x plus 3 cubed times the derivative of the denominator function, which is cos x differentiates to minus sine x. So minus sine x, and since this is multiplication, I just put that inside a bracket, just to keep track of the operations we have here. And yeah, so that's it for this differentiation. Now let's do the last one. Okay, so for this one, again, as usual, we square the function in the denominator, then we write down the function in the denominator times the derivative of the numerator function. So in the numerator is a trigonometric function, and the thing about trigonometric functions is that depending on what type of function we have, we need to use a different differentiation technique. So we can't really generalize them with a single method. So in this case, this is the type of functions, trigonometric functions, that we need to use chain rule, because we just have one single trigonometric function with a power. So we can use chain rule for this one. always using identities is an option, and always consider that, but in this case it's quicker to use chain rule, probably quicker. So if you use chain rule, basically just the same as usual, just to show you here very quickly. Let's just say that your function g of x is sine squared x. So this is sort of like having sine x and then bracket squared. So this is very similar. This is basically the same thing. And if you differentiate this using chain rule, the power comes down, which is 2, times the derivative of the inside of the bracket, which is cos x. So sine x differentiates to cos x. And then times, again, the bracket, but the power minus 1. So 2 minus 1 is just 1. So this is going to be your derivative. So we just need to copy and paste that here. So ln x times 2 cos x sine x, then minus, so this time we write down sine x squared times the derivative of ln x, which is 1 over x, as we have had that multiple times. And this is the final answer. Okay, that's it for this video. Thank you for watching.